All right, let's do this thing. So here we have two examples of right triangles, and the instructions merely say to solve each triangle. All right? It doesn't really give us anything other than that. So when it says solve each triangle, what it actually means is find all unknowns. All the sides, all the angles. All right? And the idea is that in a right triangle, all you need is one side and one angle, or two sides, and you'll be able to find everything else about that right triangle, which is super useful, especially for those of you planning on going into construction. So let's look at this problem here. Again, you can ignore the fact that it says 17. Yeah, don't worry about that. So let's see. We've got this 22.6 miles, and we've got this 62 degrees. So what we're looking for, and I'm going to go ahead and mark them, we're looking for this angle. I'll call it A degrees. We're looking for the hypotenuse, which I'll call little c. That makes sense since it's across from big C, and we use C to indicate the hypotenuse anyway, right? And let's see, I guess that means we will call this not A. I'm going to go back to theta, and we're going to call this side A. Again, X, Y, MN, happy face, sad face. The symbols you use don't matter whatsoever. I'm going to use little a for the short leg and C for the hypotenuse, and then that theta, it's a Greek letter. We use it for angles all the time. Okay, so speaking of theta, I think that's going to be the easiest one to find. But for right now, as usual, I would like you to go ahead and pause the video. Take a look at this triangle here. I'll zoom in even more for you. Take a look at this triangle here, write it down on a piece of paper, and see if you can find these three things. We're looking for the angle, right, you can't see what I'm pointing at. We're looking for the angle and the hypotenuse and the short leg. Ready, set, go. All right, so I think the easiest thing to find is going to be theta. I'm going to solve for each of these separately, and I'm going to use different colors. So I'm going to leave theta green. I'm going to make C blue, and I'm going to make A purple. Okay? That way you can tell my work apart, essentially. Okay, so let's start with theta. And theta is going to be the easiest one to solve for because we know that all triangles add up to 180 degrees. And since we already have an angle that's 90 degrees, we know that theta plus 62 degrees is the one that we've got, that those two together have to make 90, so that the whole triangle makes 180. So theta is going to equal 90 degrees minus 62 degrees, which is, you got it? 28 degrees. To do that, by the way, in my head, I know it's only subtraction, but I'm gonna give you the behind the scenes peek anyway. I started with 90 minus 60, which I knew was 30, and then I subtracted the other two to get 28. All right, so we're already a third of the way there. We've got ourselves a theta. So now which one am I going to solve for? Well, I could do A or C, and it really doesn't matter. I'm going to go ahead and do A I guess, next. So I'm going to separate this out. So that we don't get confused. I want to make sure that solving for each piece is totally separate work, because when you're solving for multiple things, it's very easy for the work to all get mixed up, and then you get completely lost. So really, really stay organized. So for A, what do we have? What do we need? Well, I'm going to continue working with this 62-degree angle. Even though I now know the other angle is 28 degrees, I could use that in my proportions if I wanted to. But if I'm looking at this 62-degree angle here, if I'm looking at that angle right there, then what I have is the opposite leg. Right? What I have is the opposite leg. Opposite. All right, so what do I need? Well, again, if we're solving for A, then A is the adjacent leg. I can tell this is the adjacent leg because it is the leg that is part of the 62-degree angle. Right? The 22.6 miles has to be opposite because it is not touching that angle B. It is maintaining its social distance. Okay, so we have the opposite, we need the adjacent. Oh man, I haven't written this in a minute. SOHCAHTOA. I wonder if any of you actually wrote it on your hands. I hope some of you did, but I'm inclined to doubt it. So we have the opposite, we need the adjacent, we're using SOHCAHTOA. Looks to me like the only one of these three that has both opposite and adjacent is tangent, TOA. So we're going to say that tangent of 62 degrees equals, now again, opposite over adjacent. Tangent, underlining it, is opposite over adjacent. The order matters because if you flip over the fraction, then you're essentially going the wrong direction. So opposite is 22.6. Adjacent is what we're looking for. And that's the setup. If you can get to this point right here, let me zoom in, because we're going to need to do some stuff with this in a bit. If you can get to this point right here, you're doing pretty well given how long we've been doing this and given the limitations of remote learning. All right, so if you can get here, you're doing pretty great. Now, to do this algebra, I'm going to put this tangent of 62 degrees over 1. I'm not putting it over 1. The over 1 is already there. I'm just making it visible. And then we're going to cross multiply. That way, that way. So tangent 62 degrees times A. Some folks are having a hard time with this. Just remember that tangent of 62 degrees is just a number. Pretend it's like a 4. If you had 4 times A, the answer would be 4A, right? So if I have A times the tangent of 62 degrees, that's just A times the tangent of 62 degrees. Don't let the fact that it's in the opposite direction bother you. You could put the A on either side. Equals, let's see, 1 times 26, 1 times 22.6 is 22.6. Again, remember that tangent of 62 degrees is just a regular, ordinary, plain old number, right? Don't be afraid of it. So we're just going to divide both sides by that number, just like it was a 4, right? If this was 4 times A, we would divide both sides by 4. Since it's tangent of 62 degrees times A, well, that's what we're going to divide by. Tan 62 divided by tan 62 is 1, so we're left with just A on the left, and that equals 22.6 divided by tangent of 62 degrees. Now, I'm going to go ahead and switch over to the Google calculator. Again, if you just type the word calculator into Google, you will get a fully functional scientific calculator. Now, going back over to, it was 22.6 divided by tangent of 62 degrees. Now, first things first, very important that we remember this and check on your own calculator. The Google calculator defaults to radians, okay? Because in later math, the Google calculator defaults to radians, and that's because in later math, radians become much more useful than degrees, so it's kind of assumed that you're working in radians unless you specifically say degrees. So we're going to specifically say degrees. See how degrees is now solid and radians is now gray? That means we're in degrees. 22.6 divided by tangent 62. 22.6 divided by, I wonder if I could just type it in. 10? I can, that's kind of cool. But I'm going to go ahead and hit the button. Tangent. Wait, it wasn't 62, it was 52. It was 62. This is why you write stuff down, because my memory is just awful. And then equals. We get 12.016. It didn't specify what to round to, so we'll just say 12.02. Do we have units here? Miles. And that gives us, I made it purple, our answer for A. We are 2/3 of the way done. So I'm going to leave this here for a moment. Now it's time to solve for that last side C. I can think of at least 4 different ways to do it. Take a moment. Now that we know what theta and we know what A are, and think, how can you find that last side of a right triangle? So there are a lot of ways that you can do this. The fastest way is not going to be the most accurate, and I'm going to show you both, all right? So we could find C, we could find little c, by looking at 62 degrees again and doing another trig ratio, right? We could say, well, we've got 22.6, which is the opposite leg, and we've got what we're looking for, which is the hypotenuse. So let's see, SOHCAHTOA, so sine is opposite over hypotenuse. So we could use sine of 62 degrees, set up another proportion, and solve it, and that would 100% work, and it would actually probably be the most accurate way to do it. But we do have another option. And our other option is the Pythagorean Theorem. A squared plus, I don't want that to be confusing. I'm solving for C here. I'm just labeling that. A squared plus B is 22.6. So 22.6 squared equals C squared. Yeah? 12.02 is what we solved for the shorter leg. 22.6 is the longer leg, which we had. So, Pythagorean theorem. Let's move back over to the calculator. 0.02. Actually, let's do this all in one go. I'm going to say the square root of 12.02. Does not look like there is a specifically squared button, so I'm going to say to the 2 power plus, what was the other one? 22.6. 22.6 to the 2nd power. And since I put the square root right in front, I should just hit equals and get what I get. 25.597, so we'll call that 25.60. If you don't remember how to round, I'll drop a video link here. And that's it. That's the triangle. We now know everything there is to know about this triangle. We found all of its sides. We found all of its angles. I'm going to give you a minute to process that. And by a minute, I mean I'm going to move on, but you should pause the video and really think about this and put it in your notes. Because the next example that I do, I'm going to do much faster. Okay, I'm not going to explain every single step. I'm just going to kind of move my way through it. Okay, here we go. We've got this other right triangle, and it's got a 51-degree angle. So I am going to show my work here, though. Like, I'm not just going to label this as, what's it going to be, 39? I mean, that's true, but this is a math class. You have to document your steps. Okay? So theta is 90 degrees minus 51 degrees, which is 39 degrees. That way the whole thing makes 180. If you are uncomfortable with that just 90 minus the other angle thing, you could always have all three angles add up to 180, right? You could say 90 plus 51 and then subtract that off of 180. That would also be just fine. Okay. So I'm looking for A, I'm looking for C. Let's start with the hypotenuse this time. So I know that from angle 51 degrees, I have, let's see, I have, from 51 degrees, I have the opposite leg. And I need the hypotenuse. So, ka, toa. Opposite and hypotenuse. That looks like sine to me. So I get sine of 51 degrees equals opposite over hypotenuse. Opposite is 9 inches. Hypotenuse is C. Now, before I move on, I want to mention that you could have been looking at this angle, this 39-degree angle. We could use that as our reference angle instead. There's really no reason to choose one or the other. If we used the 39-degree and we were looking for C, then we would use cosine, right? Because we have the adjacent and we'd be looking for the hypotenuse. Ka, C-A-H, is adjacent over hypotenuse. And maybe that should start getting you thinking about how these ratios and these angles relate to each other. because cosine of 39 degrees is always going to be equal to sine of 51 degrees because they're the same ratio on the same triangle. So try to wrap your head around that one. Okay. Zooming in, we have sine of 51 degrees equals 9 over c. Put it over 1, cross multiply. C times sine 51 degrees, well, there's no real way to combine those, so I'm just going to say C times sine 51 degrees. And then 9 times 1 is 9. Divide both sides by sine of 51 degrees. Is my phone in reach? 1 second. Hey Google, what's 9 divided by sine of 51 degrees?
The answer is approximately 11.580836.
Approximately 11.58. Were we given units? Inches. All right, we've got C. Notice how even though I've got space over here to the right, notice how even though I have space there, I'm not using it. I am going in a vertical column. I want all of my work to be vertical so that I can always tell which step came in what order. If I was to start writing a bunch of stuff out here, then it could be very, very easy to confuse myself if I make a mistake, or confuse your teacher when they're trying to grade you. The easier it is to follow your work, the less likely you are to make mistakes, and the more likely you are to get lots of partial credit even if you get the answer wrong. All right, now we're solving for A. We've got two sides of a right triangle, so I'm going to go ahead and use the Pythagorean Theorem, and I'm going to say that A squared plus B is 9 That's kind of confusing because this diagram uses A, B, and C in a slightly different way as angles instead. But remember, the labels are arbitrary. So A squared plus 9 squared equals, we just found the hypotenuse, 11.58 squared. With a little bit of rearranging, you get A equals the square root of 11.58 squared minus 9 squared. If you didn't follow that, what I did was subtract 9 squared from both sides, and then I square root both sides. Hey Google, what's the square root of 11.58 squared minus 9 squared? I don't think it's going to do it. Yeah, I don't think it's going to do it. All right, we'll actually use the calculator. All right, square root of 11.58 squared minus 9 squared. You can do all of these commands on the keyboard, by the way, instead of actually hitting the buttons with the mouse. It just takes a little bit of getting used to. 7.286, so we'll call that 7.29. I think this was inches. And that's the second example. Okay, I got one more for you. This one I came up with on my own. Solve the triangle. Now, in this case, we are given two sides instead of a side and an angle. So we're going to have to solve for an angle, which I know is a little bit rough for some of you. So let's get that started. Let's call this, I don't know, x degrees. And we'll call this angle like y degrees. And I'm going to still use c for the hypotenuse because that's just kind of what I've been using. Now, obviously, finding c is going to be the easiest part here. Let's change there we go. We get c squared equals 3 squared plus 4 squared, right? Using the Pythagorean theorem, but actually, this is another special right triangle. We don't really talk about it, but this is a special right triangle in that we call it a 3, 4, 5 triangle for a reason, right? Because then we get c squared equals, well, let's see, 9 plus 16 is 25. We get c equals 5. That's why this is called a 3, 4, 5 triangle. And it doesn't just work with 3, 4, 5. It works with 30, 40, 50. It works with 6, 8, 10. It works with multiples of 3, 4, and 5. But anyway, you can still use the Pythagorean theorem. Now I'm going to pick one of these at random to solve for first. Let's say x. Now, x is a tough one. We're solving for an angle rather than a side, right? We're solving for this angle, which, again, requires us to reverse our sine, cosine, and tangent. Speaking of which, so if we're looking for x degrees, well, we have all three sides. It literally, legitimately does not matter which sides we use. So I'm going to go ahead and say we're going to use the adjacent and hypotenuse, and we'll do cosine. Okay, because I don't think we've done cosine yet this video. Okay. So I could say that cosine, what was that all about? That cosine of x degrees, so I don't know what the degrees are. I don't know what the angle is. Okay? Normally I know what the angle is and I need to use cosine to find a ratio. This time we're going to know what the ratio is and we're going to backtrack that to find the angle. Okay? So that equals adjacent over hypotenuse. Let's see, cosine is adjacent over hypotenuse. Ooh, I forgot to write it. So, ka, toa. Sorry, almost forgot. So yes, cosine is adjacent over hypotenuse. Adjacent to that x is 4 meters. Opposite is 5 meters. Now, from here, we have to uncosine both sides, right? We have a ratio, but what we need is the angle. So cosine doesn't do what we need it to do right now. Cosine takes an angle and it spits out a ratio. What we need is the anti-cosine. And on your calculator, the button will look like cosine -1. Like to the negative first power, which we're going to do to both sides. The cosine and the inverse cosine cancel out, and we get x equals the inverse cosine of 4 over 5. Okay? Now, again, I'm going to show you how to do this, all right? Back to our calculator. Clear. Every calculator should have a a second button or a shift button. In this case, it's an INV button. It's right there. Stands for inverse. And what it does is it undoes whatever. So if I hit that button, inverse, do you see how the sine, cosine, and tangent have all changed to sine -1, cosine -1, tangent -1? Now when we hit that button, it will take the ratio that we feed it and give us the one angle that matches to that ratio. So once you know the ratio of the two sides, you can use that to find the angle, which again, if you're building things, is just ridiculously, ridiculously useful. Okay. So I'm going to say cosine inverse. Oh, good. It even says arc cosine. Remember from the last video, arc cosine is just another word for cosine inverse. All right. It's just another word for undo cosine. All right. So, and I actually prefer calling it arc cosine because I think the exponent's confusing, but that's just me. So we get arc cosine of, I believe it was 4/5. Remember that over just means divided by. And I hit equals. 36.87 degrees. 36.87 degrees. X is about 36.87 degrees. Places where you can go wrong here. All right, places where you can go wrong here. First off, as before, make sure you're in degree mode. If you're in radian mode, you're going to get a weird answer. But that's good to know, because if you get an answer that's really weird, or worse, if you get an answer that's negative, you should be able to recognize that as, oh, I bet my calculator's in the wrong mode. Also, let's see what happens if I accidentally got my ratio backwards, okay? What if I accidentally put the 5 on the top and the 4 on the bottom? Okay? If I accidentally put 5 on the top and 4 on the bottom, if I did hypotenuse over adjacent instead, and watch what happens. If I say cosine -1 of 5 divided by 4, and I hit enter, it says error. And on your calculator, it might say error domain. And the reason for this should be obvious once you really think about what cosine means. Remember, cosine is the adjacent leg of a right triangle divided by the hypotenuse of that right triangle. Yeah? And the hypotenuse is always the longest leg of any right triangle. Any right triangle in the world, the hypotenuse is the longest leg. So if cosine is defined as the adjacent leg divided by the hypotenuse, it must always be less than 1. It's always going to have a bigger number on the bottom of the fraction and a smaller number on the top of the fraction. It's impossible for cosine to spit out anything that's bigger than 1. It's just not possible. There is no ratio of adjacent over hypotenuse that will give you a number that's more than 1. And once we've got this, we can do some quick subtraction, right? Hey, Google, what's 90 minus 36.87?
The answer is 53.13.
So we get y is about equal to 53.13. Showing my work messily and off to the side. You shouldn't do that. So there's an example that involves having to solve for an angle using arc cosine. I'm probably going to do another video soon specifically about arc sine, arc cosine, and arc tangent, and really digging into how they work. But it really isn't anything more complicated than what I've already said. It's just an undo button on sine, cosine, and tangent, right? We came up with sine, cosine, and tangent because we knew that those ratios are always going to be the same no matter how big or small the right triangle is. But small right triangle is. Arcsine, arccosine, and arctangent just give us a way to reverse that process. That's all I've got for you today. I hope I will see you in Zoom fairly soon. Make sure you're checking your email. Make sure you're checking Google Classroom, all that other good stuff. Stay safe. Stay happy. Class dismissed.